Okay, now we're going to look at section 5.3. It's page 61 in your workbook, Systems of Equations, the addition method. So really what we're trying to do here is eliminate one of the variables by adding them together. So our whole goal is to get one of the variables to have a like coefficient but of an opposite sign, so that we can just add those two equations together and get that to totally cancel out. So here's the kind of layout here of instructions. Choose a variable to eliminate. Choose the variable with the variable terms with opposite signs, same coefficient, or both if possible. So now if that's not possible, we have to make it be that way. So we're kind of going back to fractions where we need to find a lowest common multiple. So we need to multiply through on both sides one of the equations that's keeping balance. So we're okay to do that. If these were expressions, we wouldn't, do that and keep equivalency, but they're equations, so that's a good move to do. And then we can force one of the coefficients to be the same. We want to make sure that we do the opposite sign also. And then once we get that, we can do that same back subbing, or we can do the whole process again and cancel out the other variable or eliminate out the other variable and solve that way. Sometimes that works really well when we have fractions and it's kind of messy to back sub. It's actually easier to do it by elimination. Now this process, it conceptually is a little bit tricky, especially with the lowest common multiple thing, and it's probably something brand new to a lot of you and you're not used to it. But once you get used to it, it's actually really efficient and nice and one of the better methods to use. So I'm going to leave the directions right here for you to be able to reference, and we're going to look at these two equations. So they're set up as a system, notated by these braces, or it'll say solve the system by addition / elimination. So on a quiz or a test, if I specify a specific one to use, then you need to use that in order to get full points. So we have negative 8x minus 3y equals negative 12. And the second equation is 2x plus 3y equals negative 6. So we're going to look for something that has the same coefficient but opposite signs, and I see that right here. So what I can do is just really nicely on this one, just draw a line and add. So we're always adding just to make it easier instead of thinking, oh, if they had the same sign, why couldn't I just subtract them? Well, in essence, that's what you're doing, but it makes it all easier to work with if you just keep it as addition, because then you don't have to worry about like negatives, things like that. So if I go ahead and add these, I have negative 8x plus 2x gives me negative 6x. And then the minus 3y plus 3y is plus 0y. Right, but I don't really need to write that. I'm just going to leave that out. And then I'm going to actually put a line through it. Make sure it actually does cancel, because sometimes people don't look at it as the right thing. They kind of make a little mistake, and then they didn't notice that it just really didn't zero out. They're the wrong sign or something. So make sure that actually zeroes out. And then negative 12 plus negative 6. We have negative 18. Divide both sides by negative 6. And I get x equals 3. Now again, I could just take that and pop it in to the other equation, which is how I'm going to do it. That's what these directions say here. Actually, I could just do it into either equation, right? Because I didn't really manipulate either one. So I'm going to plug in for that top one. So I have negative 8 times 3 minus 3y equals negative 12. And then I'll get negative 24 minus 3y equals negative 12. Negative 3y equals 12. Divide by negative 3. I get y equals negative 4. Now, if you were to plug into this one, you would get the exact same answer. Okay, you can even do that to double check. And then the answer I want to write as a point, just like I've been doing before, so that it's really easy to track what your answer is. You can verify by putting both points into each equation. I'll write the verify over here off to the side. And you can do that on your own. You can also graph them to make sure that it works, that you get that point for your intersection. And here we can see we are good there. We get that checks out. The other one I can check out also. 2 times 3 plus 3 times -4 equals -6. Remember, I do need to have these always fitting both equations, right? So if it fails for one, it fails the whole system. But in this case, both work. I verified, and that is my answer. So this one's a little trickier because it doesn't have right off the bat where you can see something that matches with opposite signs, but I can make it be so. I'm going to look at the y values here because I think they already have opposite signs. If I just multiply this by 4, then it would become -12y, right? If I had a -12y here, then I could, cancel those, would go to 0. But I can't just multiply that one term, right? That would be out of balance. I have to multiply the whole entire equation, both sides, by 4, and then distribute is what I'm doing. So let's write that over here. We would, I'm going to rewrite the -5x minus 3y equals -3, just right here so I can work with it and show you. And then I would have, I'm going to multiply this side by 4 and this side by 4. So we're keeping in balance, or you could think of it as the whole equation, every term by 4. And then this would become -20x minus 12y equals -12. Okay, so that is what I have. This equation has now become a multiple, right? So if I rewrite this second equation, -7x, I'm going to put that right down here, plus 12y equals 12. So I just left that one as is, didn't change it. And then I write my line across and add them. Okay, so now I look and I can do those definitely zero out. So I'm on the right track and I've done it correctly there. -27x, when I add those two together, equals 0. Now that's okay. Don't let zeros scare you. Zeros are good. They're easy to work with. Then I divide both sides by -27. And again, make sure you follow through. Don't just leave it as 0 over -27. It's 0. 0 in a numerator is 0. You could go 0 times -27 and get 0 back. So it's not undefined. Sometimes people flip-flop those around. So be aware of that. Be careful of that. So that is my x value. And again, I could take that and I could just plug it into the other one. I am going to show you that. So let's do that first. And I could just plug that right in for x. I say other one, but an original, I should just say either of the originals is what I can plug that into. So I could put it in this one. I wouldn't want to put it in over here where I manipulated. So I would have to put it in the original here or here. So I'm just going to pick this top one. -5 times 0 minus 3y equals -3. And I would get 0 there. So -3y equals -3. And I get y equals 1. So my answer would be 0, 1. Okay. Now I'm going to show you if we had to deal with getting an opposite coefficient match when we don't have a common denominator on either one. So that I want to try to manipulate this equation. So this is, instead of back subbing, I could get rid of the x's on this one, but it's a little trickier. So let me just show you that. So I need to have a common coefficient on these x's. So I would have to multiply this -5 by 7. So I would multiply every term, 7 times -5x minus 3y equals -3 on this one. And I would also have to do the same here, multiply by the 5. I would pick -5 because I want to make sure I have opposite signs. And so I would have -7x plus 12y equals 12. And then I'm going to distribute each of these. And I'm going to get a couple of new equations under here. So let's see. So we have 7 times -5x would be -35x minus 21y equals -21. Then we have on this one, we'll have a positive 35x. Okay, so I'm working right here. Then a -60y equals -60. Then I go ahead and add those together now that I have my opposite signs, right? So I'm going to have these zero out, and I get -81y equals -81. Divide both sides by -81, and I get y equals 1. So I get the same answer. It's just I can back sub to get it. This is called back sub. And then this other method is just eliminate other variable, which was tricky in this case, but sometimes you just can't get around that. So I wanted to show you how you deal with that when you have to get a lowest common multiple and you have to just multiply by the coefficients of the other one so that they cancel out. So that's definitely a challenging aspect. So try your best with that and see how it goes. I mean, you're just learning this. So try the simplest approaches first and then work your way up. Okay, so here's one where we're going to solve by elimination, but we don't have a like coefficient. We have to figure it out. We don't even have anything like just easily available to multiply. So I'm going to focus on the x's. So I have -6x plus 4y equals 26. And I have 4x minus 7y equals -13. So what I'm going to do is rewrite this one as multiplying by to get a common, we'll say we're looking for -12x in the top there and a 12x in the bottom. We already have opposite signs. So if I multiply this top one by 2, actually I can just do this whole thing by 2, right? And then the bottom one I can multiply by 3, and I'll be in business. It'll work out really nicely. So I'll have -12x plus 8y equals 52. Then I'll have on the bottom there 12x. So remember, I'm looking for the opposite signs. Minus 21y equals -39. Then I add them together. These zero out. Always do double check that. Then I'll get 8 minus 21y. I get negative 13y equals 52 minus 39 is 13. Do make sure everything's lined up with your like terms. You know, that's definitely important, as you'll see later if they're switched around. And then we end up with y equals negative 1. Okay, so that's my y value. Again, I can back sub that in, or I can eliminate the y's and do it that way. This one I feel like it's pretty easy to back sub in, but I want to show you what if I went the other route and I multiplied out and eliminated the y values, just so you can see how that works again, or if you want to try that. But you can go ahead and back sub. You should get negative 5 for your x value. Okay, so off to the left here, I rewrote the system. I wrote it as 7 times the negative 6x plus 4y equals 26 on the top, and then 4 times the equation on the bottom, right? So that way we will be able to get a common y coefficient of opposite sign. So this will work out to be negative 42x plus 28y equals 182. Then on the bottom equation here, we have 16x minus 28y, which is what we're looking for there. And then the 4 times the negative 13, we'll get negative 52. Then go ahead and add them together. These cancel out. I get negative 42 plus 16 is going to be negative 26. X equals 182 minus 52. It's 130 divided by negative 26, and I get negative 5, which is what I'm looking for. Again, you can verify by graphing. You can verify by plugging in. Okay. And just let me know if you have questions with that. The concept on that is challenging. It's a high level thing, but it's really something you want to get down in this class. It's not explicitly taught later, even in your 99 that you'll take next. You're expected to know it. I will have at least just one problem that you have to, use this method and stuff, but I'm not going to fill a whole quiz or test with them. All right, so we have a example 514, solve the system by addition, and in parentheses we always put elimination. It's often called that as well. So we have the system 3x plus 7y equals 2, and we have 10x plus 5y equals negative 30. So this one I want you to pause and do as classwork. Okay. Let's see the next one. This is special cases. Again, you're going to come up with scenarios that just you get an untrue statement, something that's parallel lines, or you might get a true statement where it's infinite number of solutions, or you might see that they're actually the same line. So I'm going to encourage you to try those on your own. I will go through all of these as well in the video, but if you want to just go ahead and skip up this answer for 514 should be negative 4, 2. So I think if you're getting that and you're able to follow the process, just write it out, make sure you turn it in and everything, but you don't have to watch the whole video. And then here, this one is going to be no solution. And again, we call that inconsistent. And this one is going to be infinite number of solutions. You can abbreviate that. And that is, again, that's consistent, but it's dependent. All right. So go ahead and try those. And then if it's just not going well, you're not getting it right, then finish out the video. If you got it, then you're all good. I may actually just do these all in a separate video. So I'm going to end this one. It's just getting kind of lengthy. And then check back the other one if you're needing the classwork pieces.